Good morning, everybody. We're going to go ahead and get started with our session here today for the October version of the Pigment 101 webinar series. Today we're going to talk about color other than pigment powders. That could be in the liquid form or in the solid form in terms of dry pigment preparations or granules types of things. So there's a lot of uses for this in various industries. So I hope to be able to give you some overview into other options for color to your formulations other than grinding the pigment powder yourself. So with that, we'll go ahead and get started. I will be recording this, so all those in attendance today will receive the link to the recording as well as the PDF of the presentation. And as always, if you have any questions along the way, feel free to use the chat box and I'll address all of those at the end of the presentation. So with that, I will go ahead and get started. So as I mentioned, we're talking about color other than pigment powder. Oops. There we go. So a lot of differences between the two, and I just wanted to point out a few of the key ones that might be advantageous to you as a consumer. Obviously, no dust, so there's no waste of the physical pigment itself. If none of the material goes up your ventilation system as you're dumping the bags into the batch in there. Also, likewise, there's no waste coming from the actual packaging materials that they come in. So that's one advantage of that one. Because they are already dispersed, they are already at their optimum color development. And then that also allows you to be able to formulate your products in minutes, so to speak, to be able to mix everything together. The liquid versions are pumpable and easy to dispense via a pumping system or a dispenser application area. You can reuse the containers that they come in. It also allows for lower cost operations. So you're now just mixing things together versus using dissolvers or media mills to be able to generate that dispersion first. It's cleaner operation, as I mentioned up there. In this case, you really only have a tank to clean versus the cleanup of a media mill. It does allow for you more of a mix and go formulation with the ability to reach a lot of shades of color. And then it does offer you that higher production efficiency and more importantly, some very consistent quality, first-time quality. So it's really nice to say that, from a liquid dispersion or even the dry dispersion, it's really just a pump, mix, and ship type of application area to be able to do that. So it makes the system very efficient for your applications. This is just a schematic of all of the various steps that go into making a dispersion that a liquid dispersion or even a solid dispersion as well, all the way from the synthesis of the pigment throughout the dispersion process, and then finally into the final application of the liquid paint or plastic types of areas. So it really does lower the overall carbon footprint, less capital investment, lower operating expenses, and a cleaner operation. Again, going back to that pump, mix, pack, and ship type of philosophy. So Liquid dispersions, if that's the route that you're going to go, we as a supplier of those, we take care of creating that dispersion and making sure it is the pigment is fully wetted, it's ground to its optimum position, and then fully stabilized so that when you receive it as a raw material, that it is ready to go and ready to use. Just a little bit of a philosophy of what's important in here, just a little bit of a video to share with you on dispersion stability. So this is what you don't want. You don't want that those pigment particles to come away, to flocculate, to and then be unstable in the system. So because we are preparing the dispersion, these come like this with fully stabilized, and each of the pigment agglomerates or aggregates are separated from each other and fully stabilized so that it is optimal space and ready to use in your formulation. So it's very important to understand how to interpret what a dispersion is and how they're sold and what's important to know about a dispersion. So just looking at the price per pound is not necessarily the way to look at it because they're all very different in terms of their cost of usage. So you heard me use the terminology of value in use. This also goes into hand with cost of usage in there. So the example that I brought for this presentation is so there's a dispersion that we talk about here. Sudarshan prices that, for example, at $5 per pound. A competition may see that as a $4 a pound type of product. Same color index, if you will, but different in terms of the sticker price in there. So the thing to consider is that what that value in use is between the two. So for example, in our Colonial 500 series, there's an example where one of the products is 41% colored pigment. So really any competitive product below 33% is actually going to be more expensive to use than the Sudarshan product. So that key thing about pigment loading, colored pigment loading, is important to understand. And then the other thing is also to pay attention to when you see that total pigment labeling on the TDS, is to understand what exactly that is. Is it just the colored pigment, or are they counting any extender pigments that might be in that formulation? So if you see something that might be the total pigment content might be 50%, that maybe that is 25% colored pigment, 25% extender. So you can test that via just strength in the lab to be able to validate that comparatively in there. So getting an equal pigment to pigment basis is the first thing, and then a strength to strength basis is the second item to be able to compare two different dispersions. And that'll allow you to understand what that cost of usage is, as well as what the cost and value in use might be. Selection of the pigments, again, we've this is something that is not new, and but also has to be considered depending on your application intent. Is it going to be interior or exterior? Interior, of course, price really is the key here, because a lot of the pigments will fit in this area as well. So you want to be able to get the most value out of your formulation as possible. If it's going to be an exterior application there, that's where the higher performance pigments come into play for that additional UV stability that's required. If the formulation is more in the silicate or line base area, pH stability is a key area that has to be considered when choosing your colorants, so that there's no interaction between the base and the colorant. And in some cases, all three of those are in combination, more of a universal type of approach. Here, then, it's more of a balance between price, UV, and pH stability in here. So um, the, um, the whole aspect of that one is balancing out all of your attributes that you're looking for. In terms of weathering performance, there's a lot of choices to make. And this again goes back to whether it's going to be, what kind of weathering expectations are there. So in the red color space, there's a lot of color indexes that will work. And it's really good to understand the selecting the right ones. So for an exterior perspective, certainly you wouldn't use a red 112 chemistry in your system because it has very poor performance for exterior. Coatings markets, we all know they're very complex and they can be very specialized as well. Generally, they fall into two broad categories, architectural and industrial. Architectural ones, you tend to think of the things that you can get at home centers for house paints, stains, varnishes, aerosols, and the like. These are all applications that are very useful for liquid colorants. They can be both water-based and solvent-based in their formulation types. On the industrial side, these are more specialized, and typically they're designed to function for protection of the substrate. You can also get them in the home stores, or more from the factory direct to purchase aspect of it in bigger batches. A lot of different types of formulations that go into these types of industrial coating formulations, from enamels to directed metal, epoxies, urethanes, lacquers. All of these are suitable for using liquid colorants in these types of formulations. As I mentioned, they can be water-based, solvent-based, 100% solids, especially for those UV areas. This is just a quick sort of cheat sheet to use from the Sudarshan perspective for the various preparations that are available and where they're most applicable from an application perspective. All the way from the colonials to the hostatints and hostafines, and the like. There gives you an idea of what types of systems they're good for, a little bit of the information about them and the application areas where they are best suited and where they may not be suited for. So that's a good handy overview to be able to hold on to for selection. As far as architecture, we've talked already about interior versus exterior. Interior definitely need light fastness aspect of it, as you can see from the photo here with the windows allowing a lot of light into more of the more recent house designs in there. So light resistance is really important. Not necessarily UV, because a lot of these windows in today's marketplace do filter out the UV area. The next thing to consider is, dirt. People are going to clean their walls, so some scrubbing resistance might be of importance in here. So, part of the formulations that these go into allow for all of the paint making additives that you need to do to be able to put in there, because the pigment concentration is so high. We want to be able to leave as much room for all of your paint making additives that's required for your application here. In some cases, the alkalinity that I spoke about earlier from those substrates might be important in these types of applications as well. So pigment selection could be something that needs to be recognized in that area. but most often you're looking for the more economical organic and inorganic pigments for this type of application area. When you move to the outside, obviously the durability is definitely something that has to be considered in the selection because there is that sunlight and various types of weather, whether it be rain or frost, heat, as well as even very specific areas with respect to like acid rain, for example. In addition, there is always going to be that thought there of microbiological context. So you've got some potentially some mold or some growth on the coating surfaces with time that have to be considered in that formulation. Again, that is where these high concentration pigment loading liquids allow for those additional additives to be used in that formulation. And for the most part, the higher performance organics and inorganics typically find this space for those application areas. Decoratives for both wood and metal. These find themselves mostly in a lot of the DIY type spaces for repairing and or a refreshment of the coating. Different types of application areas from the resin side is found in these areas. Um, in this kind of case, the shades do tend to be more in the mid shade or deep shade, or even sometimes the full shade areas in there. So good coverage is important in this spaces. And then depending on the substrate, of choice. There are other requirements that you as a formulator have to take into consideration. So, for example, on wood, the coating needs to be flexible so that you can prevent cracking from changes of that wood with time, with weather, those types of application areas in there. And then, of course, on metal, there's a lot of need for protection against corrosion in there. So all of those choices then dictate what type of pigment would be required for those colorants. Point of sale tinting. So these are ones that you see in the home stores all the time. In there, they allow for very quick color on demand creation at the retail level. Typically, these are a fairly narrow set of colorants, usually 12 to 16 types of colorants to be able to provide the full color palette that is needed in those types of spaces. Um, a lot of the market needs are fixed. These types of color indexes are more or less kind of the set as far as industry standards. So sometimes it's a lot. It can be difficult to make those changes. Although in today's world, some of the outside pressures lead us to taking a look at some of those changes and how to do that. So those are the kinds of things working with a pigment manufacturer can be helpful for those. As I mentioned, about 12 or so typical color standards are used in there. Just to get a feel of what those standard colorants are used, here's the types of chemistries that are found in these type of point of sale in there. So a number of iron oxides from the yellow to the raw umber, brown, and red iron oxides are always going to show up in these types of colorant systems. Obviously, carbon black and TiO2 are mainstays in these areas. And from the organic side, you'll see a organic yellow, a medium yellow, an organic red, a magenta, and a blue and a green to be able to round out that full colorant set to be able to meet the colorant needs. If we back up a little bit into an in-plant type of tinting system, or with which is really just an expansion of the point of sale. In that the colorant set is usually larger, and also these are ready mixed color in large batches that the a jobber would tend to purchase for an application. So these provide the advantage that it's a bigger batch, so all of the containers of that batch are going to be identical from one to the other, so that as the job continues, the color consistency is right there in there. So these also take on both solvent and water, and this is really intended to be able to provide a larger quantity of the same material for application. So what I did here is just to give you an idea of what that expanded colorant set looks like. I overlapped the point of sale to this in-plant tinting list of colorants in here, and the ones that I've highlighted here with the arrows are the added colorants that to an implant system to be able to cover everything. So for example, you'll see two shades of a yellow oxide. We start to see some additional organics in the red space. And then the ones that I've highlighted in green, for example, in the red space, we've transitioned from a classical red to a high performance red space to be able to garnish some of those exterior and higher demand properties from a high performance pigment. The in the blue space, an additional shade, the green shade blue is typically added into these spaces, again, really to get to those other color spaces to be able to create all of the color spaces that are required for that application area. Universal and water-based tint. So as the name implies, universals allow for one colorant system to be able to be used in both a solvent-based and a water-based type formulation. That's done via a compatibilizer in there. It allows for some simplicity from a formulation perspective without having such a complex raw material toolbox to work with. They both have their spaces and their pros and cons. So it's really just a choice in how you want to approach your formulation type, but both are available and both are used in the industries. Transparency. It's always something to consider in the formulation. So in all application areas, there's various transparency from a requirement perspective. In a lot of areas, the more opaque is to the benefit and a requirement. Then there's regular transparent and super transparent. Super transparents tend to be those areas that are trying to compete in the space of dyes, but yet with the permanence of a pigment in here. So there are options to be able to approach that super transparent of a dye, but with a pigment instead in here. So depending on your needs and your application, the transparency provided by that particular brand of liquid colorants might be an important decision on your part. UV is a growing area as far as the space and the volumes that we see going into this area. It's a great technology, especially for the use in continuous production operations. We see a lot of it in wood and metal finishing to be able to increase that productivity from a manufacturing perspective. Another common example, of course, is in nail polish, that we see that a lot in that area. Some of as I mentioned, the advantage is the productivity for some of these industries in there because it is so fast in processing. This chart here gives you a feel with respect to the temperature requirements as well as the time in the curing process. It just demonstrates how efficient UV curing can be versus other types of coating application areas. The other area is from an environmental perspective here because they are 100% solid systems. There's no emissions of solvent, excuse me, in there. So that might be a positive in your selection. Excuse me. Printing is another area that is well versed in colorants. So a lot of ink producers may do their own grinding, and that's great. But dispersion is another area that is important to have in their toolbox to be able to make best use of their situation and their economic parameters in there. It's a very diverse marketplace as from a formulation and application area. So it's really important to match the colorant as well to the application area. And so as I mentioned, there's a lot of application areas from the more traditional oil-based lithographic, flexographic gravure we see a lot of UV curable inks in this area, the more higher tech with digital inks and inkjet types of areas. So all the way from the what I call the lower tech to the higher tech, and everything in between requires a very unique dispersion to be able to make them effective. So there's solutions for every segment in area. So there's colorants for liquids, colorants for plastics, colorants for printing, home and personal care, as well as all the other applications that fall into that special applications area that we call it, that doesn't really have a neat home in some of the other areas like seed coatings and latex types of things in here. So all areas do use colorants that are not pigment, powder pigment usage. Here's another little sheet that you can use to describe Sudarshan's workhorse dispersions and where they fit in the different application areas, and a little bit of a backdrop on each one of them to make sure that you have the information that you need when you're making your selections. So this chart, along with the table that I showed earlier, can be very helpful in your selection. Now we move on to the dry pigments. Don't necessarily always consider them as dispersions, but they are, and they offer a lot of benefits, especially in some of the plastic areas that can't take on the liquid version. And they're used in a lot of different areas. So we have in industrial coatings, we have some product lines that fit in those areas, floor coatings, PVC, transportation, road markings, as well as powder coatings can all benefit from more of the dry preparation products that are available. One example is in the Heukoplast range of products. These are based off of PVC, and they are blended to be able to provide that large volume products. Like all of these dry powder or dry dispersion blends, they are very small in dust, so they help keep the application area cleaner. The key thing here for this particular one is it provides some excellent and very accurate dosing properties, primarily because these products are typically used to shade white. And in white, you need very little concentration to be able to get that shading needs in there. So these are very appropriate for this type of application area to give that very accurate dosing. Pasta print is another form for both rigid and soft PVC. In here, again, low dusting, free flowing. These are already pre-dispersed, so they're already at their optimum quality. These are the opposite the Huicoplast. These are also are definitely are targeted for the darker mass coloration of PVC. There are high loading in there, and they will provide that good heat resistance and application areas for depending on the application area needed. Plasticine. These are the dry preparations that are well suited for coloring rubber. Both the natural and synthetic rubbers are applicable. Again, like all the other ones, these are free flowing and dust free. And they are well optimized to make sure that the maximum color development is available to the formulation. Quicoplast AZ. These are also known as flushed pigments for general plastics coloration. High pigment loading in the 50 to 60% loading area. They're based on a polyolefin carrier resin, very well used in a variety of polymers in there. So they are make for an easier dispersion for the lower shear um, single screw types of extruders, if that's what is being used in there. So they generate a good dispersion in lower energy input extrusion processes. So at this point, I'd just like to wish all of you the best in the upcoming holiday seasons. We will not have a webinar in November and December, so I do wish you all the best. We will return with the webinar series in January. So at this point, I'd like to open it up to any other questions that you might have.